People who have driven a helicopter know that a helicopter can fly up to the sky and rely on the engine. In front of the engine is a compressor. After the air enters the compressor through this entrance, it will be compressed into high-pressure air by the rotating blades. High-pressure air comes to the tail of the engine through the two sides of the pipe. There is an air inlet at the tail. Air will rotate here and enter the combustion chamber. There is a nozzle on the center axis of the air inlet. The nozzle will spray fuel outward and mix with the incoming air evenly. There is an igniter next to the nozzle. When the fuel mixture comes, the igniter will ignite. The combustion gas generated by the ignition of the mixture will generate a lot of heat and pressure. Then it will be transmitted to the propeller of the engine. It will drive the propeller to rotate at high speed. This propeller is actually divided into two parts. The two propellers behind are combustion propellers. It will connect to the compressor through a connecting axis. When the propeller rotates, it will reverse the rotation of the compressor. This will improve the efficiency of the compressor. The remaining two propellers are connected to a hollow axis. There is a small gear at the end of the hollow axis. It can transmit power. It is also the power source of the propeller. It is also called a power propeller. When the exhaust gas is completed, it will be discharged through the exhaust port here. Now let's focus on the power propeller. Let's see how it makes the helicopter take off. The power propeller is combined with several large gears through a small gear. Through the rotation of the large gear, the speed of the gear will be greatly reduced. The large gear at the bottom is connected to a rotating axis through a flower arrow. The rotating axis on the right will extend backwards. Then, through the gear at the end, it is called the combustion propeller. The rotating axis on the left will come to the transmission box of the helicopter. It will be connected to the transmission box. If you observe carefully, you will find that there is a section of the rotating axis connected to the transmission box. Its two ends have a structure similar to a spring. This structure can bend within a certain range. Therefore, it absorbs the vibration generated by the transmission box or the engine. The end of the transmission axis is a chasing gear. The chasing gear is combined with a large rotating gear. The rotating gear is also combined with a star gear. When the rotating gear rotates, it will drive the small gear to rotate together. The small gear is combined with the star gear of the star gear. So these four star wheels will also rotate together. The four star wheels are connected to a star frame through a screw. The star frame is connected to the entire propeller by a flower arrow. The top of the propeller is connected to the chasing gear. What is connected to it is the leaf of the helicopter. There is a scrolling axis that can move in this position. When it moves up and down, it will lead the angle of the leaf to tilt. Then the bottom of the leaf is connected to a shoe plate. The shoe plate is mainly divided into two parts, the upper shoe plate and the lower shoe plate. The lower shoe plate does not rotate. There is a shaft on it. There is a big ball inside the shaft. So the lower shoe plate can tilt around this big ball at all angles. The side of the lower shoe plate is a chain-linked shaft. It will be fixed to the bottom position to prevent the lower shoe plate from rotating. The upper shoe plate is connected to the shaft. There are two chain-linked shafts on both sides of the propeller. The chain-linked shaft is connected to the upper shoe plate, so that the upper shoe plate rotates with the propeller. In addition, the four corners of the upper shoe plate are connected to the leaf scrolling axis through a joint. I said earlier that the scrolling axis is connected to the leaf. So when the shoe plate tilts in different directions, the leaf will also tilt accordingly. If the shoe plate moves up and down directly, then all the angles of the leaf will change together. There is a problem. How does the shoe plate control the tilt? This requires a flight control device. The flight control device is connected to the lower shoe plate through two joints. There is also a joint that is connected to the propeller shaft. The joint is then connected to the control rod through a shaft. The control rod is driven through the 4-axis executor here. Take a closer look here. When the upper shoe plate moves up and down, the shoe plate will tilt accordingly. For the middle joint, when the upper shoe plate moves up and down, it can control the upper and lower movement of the shoe plate. Then the flight control device will be connected to the corresponding control rod in the driver's seat, so that the pilot can operate the helicopter. Now what you see are the two control rods. It is a cycle variable rod. The cycle variable rod moves back and forth. The joints on both sides of the left and right sides will move. This causes a change in the angle of the leaf. This controls the left and right movements of the helicopter. There is also a total control rod next to the pilot. When it is raised or lowered, it will drive the upper and lower movement of the middle joint. At the same time, it controls the angle of all the leaves so that the plane can rise or fall. There are two footboards under the pilot's feet, used to control the control rod. The footboard is finally connected to the control rod of the helicopter through a series of joints. When stepping on the footboard, the angle of the leaf of the control rod will change through the drive of the joint. This creates a force in the vertical direction, so that the helicopter can turn left and right. Thanks for watching. Please like and subscribe for more interesting videos.